So thank you everyone for being here. First of all, I appreciate your time. And what I'm going to be talking about is real-time analytics using Apache Pinot. So Apache Pinot is an open source project. So I'm going to talk very little about StarTree, just mostly about Apache Pinot. And with the emphasis of how LinkedIn, Uber Eats, and Stripe create real-time dashboards for millions of users. So when I first got introduced to this concept, I wanted to know what it was all about, and that's what this talk is based on. So this is the agenda for today. Who am I, or why you should be listening to me? The evolution of analytics, a little bit of history, just for me to kind of get why we're even talking about Apache Pinot. Then we're going to actually look at the case study for LinkedIn on why they invented Pinot and how they solved their problem. And we'll look at some demo and talk about some use cases. And the last 15 minutes will be Q&A. But feel free, it's a small team, so a small group, so feel free to jump in and ask questions as we go. Okay, so a little bit about me. My name is Barkha Herman, 30 years in computer science. Over 10 years doing big data and AI and analytics, even though, I learned SQL on actual IBM SQL. And also worked on the first version of Sybase SQL Server that Microsoft had bought. This was years ago. So yeah, I am older than I look. Yeah, you're right. Kicking it old school. I also run a women in technology nonprofit, which is what my next meetup is about. And I am a developer advocate for StarTree. I'll spend like the last 2 minutes talking about StarTree, but let's jump into Pinot. Okay, so analytics, real-time, scale, why, right? So that's the question that we're going to be answering. Why do we need real-time analytics or at scale? So let's look at how we got here, first of all. So back in the day, I remember, reports were generally batch. They were batch processed. So you would take like all the data from yesterday and then run a report, and people would come in the next morning and be super impressed by the report that got run. And that was great, right? So it was batch. They were slow. Reporting engines were kind of clunky. And also the reports were run on the live data, right? So whatever the data, we had one copy of the data. Maybe we had backups, maybe we didn't, but we ran it. Over time, what happened was that reporting became more like insights, and analytics became more important. So what we started doing was things like we segregated the data. So I remember I worked for, a long time ago, I worked for a company called First Data, and they do about 60% of credit card processing in the world. So they're a big deal. And so they would have OLTP data, which was super fast. And they would have contracts with their customers that they would do credit card processing under a certain limit. And if they didn't meet the limit, they would have to pay them back. So imagine you are Publix, which is a grocery store in my neighborhood, and the credit card processing system is down. You're losing money, right? So that's why they had contractual agreements for OLTP, so online data processing. That's what a transaction processing, that's what that stands for. Now, if some junior person starts running reports against that data, guess what happens? Performance goes down. And so we started segregating data based on usage. So reporting data was separate from live data. And in First Data, and this is in the late 1990s, the way we did it was we actually ran the reports on the backup. instead of the live. And there was a one-way replication that went from the live data to the old data and whatnot. Also, so then that was great, but the reports were not very, the data was fine-tuned for the old TP transactions, not for running reports. Reports were slow, clunky, blah, blah, blah. So now we started shaping the data based on the usage. So if I wanted to do, just run reports for certain data and look at it that way, we created something called OLAP databases, which was shaped extremely differently than what the old TP database looked like, right? But even through all this stuff, freshness was the challenge. So what is freshness, you ask, right? So I recently wrote an article about this, is, it used to be that I would run daily reports of like yesterday's sales and transactions and be super happy. Like, oh my God, I know up to the minute data. But now we're on our phone ordering from Uber Eats and going, where's my delivery? Is it 5 minutes or 2 minutes to deliver, right? So it's not even a day old, it's up to the minute. And you better believe that my tip will be based on how accurate that timing was, right? And depending on how hungry I am. So the data freshness is suddenly a big deal. So not only do I want reports, so that's my little, dashboard or whatever, I want it up to the minute. I want real time. So as the person is coming, driving towards my place of delivery, I want to know what's going on. Query performance is important because it used to be that, we would present reports on web pages and the timeout was about 2 minutes. And we were very happy when we reached 2 minutes. And this is, again, decades ago. I'm showing my age. And now it's like we want everything to be less than, that's not 10 seconds. It should be 10 seconds, by the way. So less than 10 milliseconds is what we want report data to load in. So the query performance needs to be really, really good. And then the next problem, and this is where LinkedIn comes in, right, is the scale. Is that it used to be that, hey, we have a dashboard and let's say 1,000 people are looking at the dashboard. Now we're talking 20 million users have LinkedIn and they want to see their who viewed my profile page. So the scale has gone up quite a bit. So that's the next issue. So let's talk about LinkedIn pace. Let's take a look at how LinkedIn solved their problem. So the shortcut answer is by inventing Pinot, but let's take a look at it. So I mentioned who viewed your profile. That is actually the first use case that LinkedIn solved with Pinot. So these are some of the challenges. So that dashboard is what it used to look, well, it still does, kind of looks like. Somebody's talking. So please mute yourself. So yeah, so what's going on behind the scenes of this dashboard? So we want to capture profile view information and its deduplication. So who's watching, who's looked at your profile, and we want to dedupe the data if you refresh the page twice and you're still one count, right? Compute view sources, example, search, profile page, etc. So where did the profile view come from? Did you show up on searches? Did you show up on profile page view? And so on and so forth. Also relevance. Is it a hiring manager, or is it just a, somebody just landed in with your profile just searching for keywords? View obfuscation based on the viewing member's privacy settings. So we all have different privacy settings in LinkedIn, and we want to render this based on, okay, if somebody viewed my profile, are they okay with telling me that they saw their name based on their privacy settings? So it's not just my privacy setting, it's also if 1,000 people saw my profile, is 1,000 privacy settings. So you can imagine the scale on that is complex. Okay, so Their original solution at LinkedIn was Elasticsearch based, was using Lucene, and they were running 1,000 nodes. So again, we're talking a distributed database. So they were running 1,000 nodes with sharded data, and they would run queries in parallel, compose it, and then render the results. So the query performance was 1,500 queries per second, which is pretty good if you think about it. And they were serving to 20+ million users at the time. Pretty good by any standards. Well, at least, if you talk to me in the late 90s or even in the early 2000s, I would have thought that was fantastic, but not anymore. So I'm going to talk a little bit about some optimization techniques at this point. So one of the things that we want to talk about is, you know what, I'm going to go here. So this is the after scenario. So initially, we were the nodes before Pinot were 1,000 nodes, and the query per second is about 1,000. So this is the blue line. And after Pinot, what happened was they had 75 nodes. So imagine that, 75 nodes, and they were serving 5,000 queries per second. And then the user count went from 20 million to 700 million plus. So that's the before and after. Okay, so what is the actual solution? And I'm going to go a little bit in the technical details here, but this is an intro session, so bear with me. It's not going to be super deep. So,
and are these optimization techniques for Pinot or pre-Pinot?
They're for Pinot. So this is
okay.
These are some common techniques, and then the next slide is what Pinot did. And that's just one of the things that Pinot did. There's a lot of, the story is long, but I'll try and go into some of it. So obviously, going against raw data is slow. You add an index, it becomes faster, right? We all know about this. Then we have OLAP techniques, which is pre-aggregation, right? And then some really uber OLAP techniques, which is cubing. So what you do is you shape the data in such a way that it's very good and very quick in to run something like, hey, give me a monthly report, give me a daily report. The cubes are perfect at that. They're best performance, but depending on how much data you want to query, the storage is exponential, right? Because the cubes are created based on what report you're running, what query you're running. Also, once you've cubed the data a certain way, it's only serving that query. It's not serving, any deviations from the query. So the flexibility is really low. So cubes are amazing, best performance, lowest flexibility, and exponential storage. The middle ground is pre-aggregated data. So, segmentation, sharding, you've heard these terms before, where we kind of group data based on a certain thing. In many cases, it's time data. So, monthly reports, yearly reports, something. It could be based on division, blah, blah, blah. So pre-aggregated data, it requires, it definitely a bigger boost on performance because you're using indexes, but the index is local to the shard. So the queries are faster. Yes, you're adding more storage because the data is now sharded. So you may have different sharding based on different aggregation, based on different shapes. And it has medium flexibility because you still have access to the entire data set, but as soon as you cross shard boundaries, so you go across two segments, now it's a little more difficult to find optimum performance, right? Okay, so one of the ways, and this is just one, and I think I have another slide that goes over a few more things that Apache Pinot has. So one of the ways to improve this is StarTree index. So there's a new index paradigm that they created, of course, because I'm new with the company and the company's name is StarTree, so I had to know what the heck is a StarTree. So it's an index that does cubing, but not cubing for everything. So the best example I found was, let's say that I'm running a website and 90% of my traffic is coming from either United States and Canada. 10% is coming from the rest of the world. Well, I can create a cube based on country, right? Which is US, Canada. The reality is the US cube is most used because as much as I love Canada, it's a smaller traffic from that. And then the 10%, which is coming from the rest of the world, if I try to create cube per country, that's just a waste of time because I'm solving for something that doesn't exist. And so that makes no sense. So the way StarTree index works is that you cube the data that you pre-cube the data that you want, and then the rest is in this thing called star, right? So it's another category. And then on each star, there's a different way to cube data. So let's say the star is everything. But within everything, what you do is I'm running a website. I'm interested in who's coming from where, but I'm also interested in what browser are they using, let's say. So now in this case, in this diagram with the really ugly labels, the D2 V1 would say be Chrome versus whatever, Firefox, Brave, whatever you want to say. And then there's the star category because there's going to be 10% of traffic that comes from, whatever browsers that 90% of the population don't use. So by actually making the cubing only for those data sets that are high used, what we're doing is we're pre-cubing, but we're not pre-cubing everything. So that's one technique, which kind of brings the cube performance with the flexibility of the non-cube stuff. Okay? Does that make sense? I thought it was cool. Here's a slide which kind of goes into a little more detail, and I'm not going to talk about all of these because these are all different techniques. Everything in the pink is unique to Apache Pinot, and the blue is stuff that other people use as well. So scanning is a technique to find data that everybody uses. Inverted index, a lot of database engines use it. Columnar store, a lot of databases use columnar store for performance. Byte encoding is used by a lot of databases. But forward indexing, sorted indexing, StarTree index, StarTree pre-aggregation, pre-segment flexible query planning, all these, and also geospatial index, JSON index, text index, range index. These are all techniques that are native to Apache Pinot. So these are all the things that they iteratively added to the product, which makes it this. Well, actually, let me go this, right? So one clue here, the geospatial was because of Uber Eats, by the way. Interesting insight. Okay, so one more thing, I'm going to go over the architecture real quick. And the reason for that is because I want to kind of show you how, Spark also does sharding of data, right? You have Apache Spark, and then you have different chunks of data. However, one of the innovation that Pinot introduced was having a real-time and an offline server as separate entities. So what happens is that your streaming data ends up through the real time, consuming through real time. And the offline server is for your batch data. So again, we talked about the differentiation between, batch consumption, OLTP and batch data. We've segregated it. So consumption is different. The segment has, a different indexes, and there's a lot more complexity that I'm not going to be able to go into it, but I just wanted to highlight some of the components. So right now the architecture is we do have a zookeeper. We're using Apache Zookeeper, using Apache Helix. Zookeeper is the keeper of all the configurations for the different servers, different pieces. We have a broker that actually does the routing and the collating. We have servers that are, each server takes care of a segment, and the segment is the actual data. So tables in Apache Pinot are logical, not physical. It's not like SQL. It's actually a logical entity, and it exists in segments, and each server maintains segments, and the segment has data, and it has multiple indexes, and all the flavors of indexes you saw in that previous slide. So, all right, so let's look at a demo. All right, so before I go into the demo, does anybody have any questions? Any feedback? Is it landing? Is this demo?
Well, Jeff commented here that the geospatial index, which comes from Uber's H3, is awesome. So he's a geospatial index guy.
Oh, awesome. Fantastic. Good to know. All right, so let me bring this. So this is where you would go. I don't want you to go there, actually. I want you to use my link to go there, so I'll get some brownie points. But this is how you would install Pinot. And so I'll share the link with you. But right now, what we're going to do is I already downloaded Pinot, and so it's a tar file that you download. And I untarred it, unzipped it. So I already have it. Let's take a look at what it is. So this is my desktop. So I'm going to go to the Pinot directory. I don't know why there are two Pinots, because I'm redundant. But anyway, or I'm not creative with names. But if you look at the Pinot directory, this is what you get when you unzip the tar that you download. And basically, you get this examples folder here. Ignore the pizza shop. That's another talk. So you get this examples folder, and in the examples folder, you will see. Can you see my screen, by the way? Are you seeing what I'm typing?
Yeah, we're seeing that.
Perfect. And is it too small, too big?
Yeah, you can up the font size.
I don't know how to do that. That's a good question. Oh, I don't want to do that. I have no idea how to do that. So I'm just going to ask you to bear with me. Okay, so I have no idea. Fan plus? Okay, let's try that.
Oh, there you go.
There you
it's
go.
under view that says you can just choose view, and there's bigger.
There you go. Okay.
Under the view menu at the top. Right.
All right. I don't know how I can kill this, but oh well. All right. So so if you look at examples, I don't know what's going on here. I'm just going to kill it.
Oh, to get rid of the split windows, it's Shift Command D in the future. Yeah, so go under the view menu, and there you go. Okay.
All right. So we're going to go to Pinot and then go to examples. And I can't type. That's why they make shortcuts. And you'll see that there is stream and batch. And we talked a little bit in the architecture slide about stream and batch. And so batch data is batch ingested, your normal ETL process, and stream sample is streaming data. So what we're going to do is we're going to do a batch ingestion scenario today. So I'm going to CD to batch, and there's a bunch of batch data. The comic book characters is mine, by the way. That doesn't come default with the sample examples, and you can imagine I'm kind of a comic book geek. So what we're going to see is we're going to look at the airline stats and the baseball stats as a sample. So I'm going to go back to the bin directory. And we're going to run a command to launch the minimum components required to run Apache Pinot, which is, if you remember the architecture slide, and we can go back to it after the demo, it's the zookeeper, the controller, the broker, and a server. In our case, all we're going to do is we're going to do the batch example. So we're going to run the batch, the Pinot. Okay, well, let me do an ls before we do that. So you'll see that there's a whole bunch of shell scripts there. The one we're going to run is Pinot admin. So let's do that. Admin.sh. And we're going to run quick start. Type. So let's do that, and it does its thing. And what it's doing is it's starting the 4 services that we talked about. So if I go to my architecture slide, it's going to start the zookeeper, controller, broker, and the batch server, which is also known as offline server. So that's what it's doing. And now that that is running, we can go to localhost 9000, which is where Apache Pinot runs. So let me go here and go to localhost 9000. And what you're seeing is the Apache Pinot server running. So this is the UI, or it's also called Data Explorer. And so you can see what we can do here. There's a query console, there's a cluster manager, there's the Zookeeper browser. You can kind of see what these are all the config. We talked about how Zookeeper keeps track of all the configs. And we have one controller, we have one broker, and we have one server. Tenant is a concept. Again, this is a logical concept for segregation of data between, whatever, departments, locations. So if you want to run a Pinot cluster, but have 2 departments accessing data, separate set of data, you can define 2 tenants and segregate that. So that's what that's about. We also have 6 tables. So let's take a look at what this is. So you can see that we have some airline stats data. You can look at the schema. And these are the segments. So we talked a little bit about segment. What Apache Pinot does is it distributes data for, parallelization of queries and all that stuff. And it has all these segments. So let's go to the query console and see if we can do some run some queries. So you'll see that it ran this really simple query, and it returned 10 rows from this data. Total documents are 9,746, but the time used is 10 seconds. Number of documents scanned, number of segments queried, so far and so forth. We can also do some things like, now, if you've used something like Spark or other Apache tech that does similar distribution of data, you'll know that this is a slow query. But in Apache Pinot, it's not. And the reason for that is because this count is not, it's part of the StarTree index, and it's not, the broker is not going to each segment and say, hey, give me how many you've got, and then adding it. It has that data indexed separately. Let's do baseball stats, run query. And then you can see things like, and again, it's really fast, but it's top 10, so of course it's fast. Let's do something like, we have some player ID and player name, and then we have, I'm not a baseball player, so runs, I know what a run is, yay. So let's do a group by, right? Let's do that. So this is a group by query. So obviously you can see it'll have to go through, go against a lot of segments. Well, all the segments really, and do a group by. And you can see that it's pretty fast. And again, the total documents are 9,000 something, 97,000 actually. And the query performance is still pretty good. So, so yeah, questions.
One question, what does document represents? Is it like record? Is it something else?
Yeah, so that's a great question. Let's take a look. So let us, can I start a new? So yeah, so can I start a new window? There you go. Okay. So let's increase the size. Where am I? So just like, so this is running locally, first of all. This is not running on a server, different different containers. Everything is running locally for me. However, if you look at what the data looks like, actually even better for me. So let's go to the examples.
Yeah, an extra Q in there.
Type.
Yeah.
I cannot type to save my life. If you look at baseball stats, right? So, and you will see that there's this folder called raw data, and that's where the data is. And it's a CSV file in this case. However, if you go to, this is where the data run by StarTree is. And let's go to segments. And we'll see that, so it's actually compressed data, and it's just showing up.
What is the size of this form?
How do you check the size? It's not
Plus,
very large.
minus LA.
Minus y?
LA, sorry. Less minus LA.
Minus
No.
what?
LS space dash minus LA.
Okay, there you go. It's not very large. So this is just sample stuff that we do. Of course, we have bigger data sets. I can go into.
Yeah, and typically this would be where like you're loading your bulk data to begin with. Like, so you might have hundreds of gigabytes or even terabytes of like historical data, right? So that's got to be ingested when you're first, starting up the system. And then that would be for like the archive data that, or something that you're bringing in from another system. But then the other thing that you do is that you then mix it with like a Kafka topic subscription. You'd have other data coming in live. So the advantage here is that you want to be able to mix both the live and the historical data.
Right. So I do have so let's go to the table definitions. This is better. This is faster. So I do have some, I'm only seeing offline.
Yeah, you can see the reported size there. Like none of these are gigabyte size.
Right.
These are just all small sample data.
Okay, thank you.
Yeah, and so to actually address the problem that you're talking about, let's actually take a look at what the data size used by LinkedIn was, right? So let me.
Yeah, like, anybody who knows professional baseball is, even if you get down to things like the pitch count, and pitch placement and stuff like that, you're still talking about just a few dozen events per minute, even across all the major league teams, right? So that's just a sample data set. That would not be a kind of a problem you'd want to throw at a Pinot because it's just not that many interesting events per second, right? But analyzing like 100 million users on a social media system, or all the commits on on GitHub or Wikipedia to, in real time, like you have to be talking about a far more large scale user base and events streaming set.
So this is actual numbers from our, and again, this is on my desktop. It's not representative of large data sets at all. But Stripe has over 1 petabyte of data and 1 trillion rows, and it's running Apache Pinot, and they're serving less than 1 second query latency. LinkedIn is consuming 1 million events per second and 200K queries per second, and the latency there is less than 100 millisecond. And Uber Eats has 200 terabytes of data plus 30K queries. So that's real numbers. I also have, the pizza shop demo. Again, even that demo, getting pizza orders every second, it's small potatoes database. We're talking right now, we're talking 1 segment. We're talking, really not at scale. This was just an example. It's not the real thing. So, but thank you for your question, Sergey.
One more.
Go ahead.
Okay.
Go ahead.
So, like I understand, LinkedIn and Uber use cases, so they kind of build application and they serve this application, right? And what in Stripe, they have much more data ingested, so I guess they use it for many different use cases. Can you provide like use cases where it's used by end user maybe, or like what is the closest to, let's say, BI, real-time BI reports or something like this? Can you
Yeah,
provide some
absolutely.
examples?
Yeah, absolutely. So, yeah, happy to do that. LinkedIn started with and if you saw the earlier, their
Yeah,
first
yeah.
solution was this view, right?
Yes.
So they had 20 million users looking at who viewed your profile, and the numbers on that are somewhere here. So that was one. Right now, LinkedIn is using it for 70 plus applications. So some of the examples, so the first example was obvious. Some of the examples that I found, and I don't know all 70, of course, but one of the examples that I found was they have a tool for businesses to look for talent. So that is a searching for talent across the world. Which area has what talent and numbers based on that. And that's one of the use cases. The other slide that I want to show you here is, these are some of our users, right? So I'll give you an example. Slack and Teams use it. What do you think they use it for? They use it for based on messages going back and forth. So they're using chat numbers. That's what they're consuming and they're representing. Stripe is a completely different use case than Uber Eats, and Jeff, as you know, I just found out has something to do with Uber Eats, is connected to Uber Eats in some way.
Not
Eats
Uber,
data is,
just spatial stuff.
yeah.
I just like spatial.
There you go. So there's a lot of geospatial stuff that's happening in Uber Eats, which is very different than, say, a LinkedIn, because there's no geospatial there. It's based on profile where you say you are, right? So that's a different use case than something like Slack, something like, so we have multiple use cases. Again, I'm happy to let either Peter or David answer some additional use cases that you can think of.
Let me go into a couple of things. First of all, like, let's say that you're doing an MVP for a company, right? And you might be building it on maybe if you're doing SQL, you might be doing Postgres or MySQL. If you're doing something with NoSQL, you might be doing it with, let's say, a MongoDB or a Cassandra or ScyllaDB, right? So you're going to be running some sort of OLTP oriented real-time transactional system, right? But you don't want to do your analytics there, because if suddenly somebody's doing a giant range scan or a full table scan on your production database, the whole thing grinds to a halt, right? So some people try to do a little bit of analytics on their live system, but they're really hampered from doing that because, again, suddenly if you're running analytics, the whole thing freezes up and it's no bueno, right? Latencies go through the roof, orders just get dropped or have to be retried, people's shopping carts get lost. So instead, what you're trying to do is then you're going to use an event streaming system and probably some sort of change data capture on that OLTP system, right? And you're going to take the event changes, the new orders, the just recently booked events, and those are going to be pumped through, let's say, a Kafka or some other event streaming system. And then you want to do your analytics off box, right? And then you're going to have a Pinot cluster that will ingest all of that stuff. So maybe you might be a big type of system that's getting 100,000 or 1 million operations per second on your transactional system. So you need to ingest at a really fast rate. And that's one of the problems with some kind of legacy OLAP systems, is that they just can't ingest very quickly, right? They're built on a kind of an ETL mindset. And so it doesn't matter how long the ingestion takes, right? But it really does matter if you're trying to marry up an OLAP system with a really fast event streaming system. And so then that rate of ingestion is really big. Then you have to be indexing in real time, right? You need to make sure that not only does the data get to the segments, but then it needs to be queryable. So again, the StarTree index is going to make it so that you can get very fast indexing on this data. And so that's kind of what you're looking at. Is if you're just building one database for a company, you probably are not looking for StarTree. But now that we're seeing that there's this ecosystem, rich ecosystems at medium-sized and large-scale companies, now you need to have like an OLTP database, a streaming system, and you're going to want to have an analytics system. And it's going to be this kind of reference architecture across whatever you're building when you're building at scale. Does that make sense?
Yeah, sure, Peter, but I understand.
Go ahead, sorry.
So I understand this piece very well, but what will be front end? Is it in examples that was provided before? It was always applications, so they have pre-canned queries to APIs, so they was getting data. So what about other use cases, like can we connect Pinot to Tableau or Power BI, something like this?
Absolutely.
Mm-hmm.
Yeah.
Right.
Yes.
And that was going to go ahead. No, you go ahead, because I have a kicker. You say what you're going to say, and I got a card up my sleeve, so I'll let you go first.
That's awesome. I love it. Yeah, so that's typically what the front end is. Of course, some of these are custom front ends, but it supports Tableau, Strim, Power BI, whatever. I mean, any UI to do to the front end. And then one of the use cases that I wanted to highlight was Third Eye, which is real-time anomaly detection, which is what we're using it for, which is amazing. So I do have an upcoming talk on Third Eye that I would love it if you attended also.
Yeah, so I was just going to reinforce that. That's exactly what I was going to bring up. In fact, I was just writing the web page for Third Eye, because we haven't. It's been a kind of a secret that we've had. It's like, again, this magician's trick. But here's the way I want to position Third Eye as opposed to a Tableau. Is first of all, you need to understand the equivalent of like business pattern recognition. What does your daily traffic supposed to look like? So you have, if you're doing, let's say, order delivery, right? Well, you're going to have the breakfast crowd, the lunch crowd, the dinner crowd, right? And so there's going to be this kind of intraday pattern that you're going to have. And then maybe Fridays are a big day, and Saturday and maybe football on Sunday is a big delivery day for you, right? And so you're going to see not just the time of day, but then the day of the week and other kinds of patterns that will emerge in your business over time, right? But then the question is, what if suddenly you have this expectation of what your typical pattern of business is, and in real time, you notice that anticipation is not being met? Either orders are through the roof, way beyond what you normally expect, or way below what you normally expect. That's what a business anomaly is, right? So when we talk about anomaly detection for Third Eye, we're not talking about like cybersecurity anomaly detection. We're not talking about the anomaly detection that goes into Grafana and Prometheus and Alert Manager. We're talking about a business anomaly, right? Something that's affecting the rate of you being able to book orders or ship and deliver things or whatever it is. Like, that's a business operational anomaly. And that's what Third Eye is specifically designed around. And again, even though you have dashboards and reporting systems and Tableau, et cetera, those are more based upon kind of like a static analysis. It's not that real time kind of thing. And that's what we're going to be positioning Third Eye to specifically do, is like, what's going on literally right now with my business. I don't need to wait till tomorrow to get the analytics of what's going on right now.
Yeah, because usually what happens is you take all the data and then you create a model and then you send it through the model, and then there's some clustering or some blah, and then there's an alert, but that's too late. You want to respond.
By the time that pipeline's gone on, that could be hours later. Could be hours, right? And it's like, why couldn't I have known at the time that I had a problem, like with my homepage or whatever it would be, right? Or the product that people really wanted was out of stock, or you need to be able to flag those things in real time, just like you would a cybersecurity incident, or again, a production operational issue with your systems. But again, it would be more at the business level is what it's trying to wrap up.
Yeah.
Yeah, thank you. One thing I noticed, like, I played with Third Eye, but there's like 20 plus models, and like when to use which model, it's not straightforward, like, at least for me. Are there any kind of decision tree? Okay, if you have this use case and you use this model versus this model, Like it's how to orient yourself in this diversity of models.
Got it.
That's definitely an issue. And so
Yeah.
if you, why don't you follow up with us after? Would that be good? Barkha, would you want him to contact you then afterwards?
Absolutely. So if you're already using Third Eye, Sergey, you probably are on our Slack already. If you are on the Slack, definitely contact me. I'm helping Madhumita, who's the running the Third Eye project.
Yeah.
I'll give her the feedback, and we're actually planning a meetup on Third Eye next week. So please come to that. But even before that, I'll talk to Madhumita, and we'll raise that, and we'll keep you in the loop on when we want to do something like that.
Yeah, but I mean, these are significant issues. And so, for instance, as an example, a data scientist might have more of an opinion upon like which algorithm to use and to throw at things. Your typical business owner isn't going to know that kind of stuff. So we're actually taking a look at like who is the ideal customer to be using this, and what kind of team do you need to have or talents in your organization to really get the most out of it. And so what you're asking needs to be addressed in documentation, needs to be addressed in training. It's definitely something that we have as top of mind here. So, but if you have that feedback, again, let us know, and we can write the docs. Let us know what your opinion is. We can change the user interface, right? This is when the product is just in this formative stage, and we really do want to hear from engaged users like you.
Yeah, and Sergey, so we're creating recipes for Third Eye right now, and we have some ideas of what the recipes need to be. Like a data set of this type, this is the recipe, this is how you would use it. But if you bring us a data set, that would be fantastic. As a matter of fact, my end goal would be to have a all-day workshop with customers bring their own data set. Mm-hmm. And we figure out how to use Third Eye to solve problems. That would be fantastic if we could do that. So.
That's great.
Yeah. All right. So now I get to ask you a favor. And if you are not using dev.StarTree, please use my link to go to it, because I get brownie points with David if you do that. So that would be great. And
you've already gotten a ton of brownie points. You're okay.
Yeah. So, but that's all my presentation. Any questions, feedbacks, comments, anything I can do to improve? And also, I want to mention that for those of you who have not used the product yet, I'm doing an early April workshop where we're actually going to do the installation and run from scratch. So I don't know, Jeff, if you're already using the product. Sergey, you sound like you are already using the product, but let me know.
Yeah, and here's my thought is, if you're not using us, I'd like to hear what you are using for this kind of task. And why are you really invested in that particular tool? It might be for very good reasons, and I'd love to hear that kind of feedback. So let me ask, how many people here do run analytics systems in your organization? Anybody want a hand raise on that, or give us a thing in the chat?
Yeah, sure. I'm using for some time.
What was that?
Yeah, I was part of architecture team. We built something similar like certain years ago, and it's still in use a lot, but it requires multiple components, so it's not for end users, so it's more like for specific use cases and scenario, and it works pretty well. But now we're moving into like we start using for the stream processing Databricks a lot. It's kind of our go-to tool, and I'm just trying to understand how to position, let's say, Pinot, Third Eye versus Databricks, because like we already have teams who have practices, who has skills, who has their patterns, and they prove something already. So, and now let's say if you need to introduce Pinot, so we sort of like what kind of benefits we can get on top, and how it will be different, how it will be better, faster, like how it can be 10x better to
Yeah.
do similar
Now,
things.
the other thing too is that Spark is not just one thing, right? Because you mentioned
Right.
Spark Streaming, there's Spark SQL, right? There's Spark ML. So Spark is not just Spark, right? There's different aspects of Spark. So maybe if you had, again, if you could tell us more, we can get into a discussion with you, we'd love to hear more about how you do use Spark and which elements of Spark you use. Because, yeah, I mean, Databricks is not going to go away. There's still a lot of people are going to be doing it, and it can certainly do things in its own inimitable way that we wouldn't want to mess with. So I think it's more a question of division of labor. Like, what are the things that Pinot does well, and
Right.
what kind of analytics we would be best at, and then how are you currently using that? And maybe Spark is the best tool for I mean, obviously it's working in your organization, but we need to know more about that. What you're currently using it for. Does that make sense?
Is it for are you using Databricks for AI, for ML, or are you using
Well, it's
Data
for
Lakehouse?
many different things. It's
Right.
used for operational, like for data processing, transformation, stateful transformation,
Right.
for like in integrations flow, but as well as used in ML by another team. I'm just representing one team that is more working on integration challenges and say real-time analytics, but we have as well ML team too. But yeah, they have different use cases.
Right, right. Got it. Yeah. Yeah. So, I mean, my background is Microsoft, and I was very closely working with Databricks for most of our ML stuff. We recommended Databricks for doing that. Yeah.
But so from your perspective, what is the sweet spot for Pinot versus Databricks? And
Yeah, so simple, Sergey, is, for ingestion and just processing, it's much, and ML, Databricks is good. Their data lake is a better implementation than most, I find. Pinot is a whole different, solution, and it is for scaled OLAP. So I don't think Databricks uses it as an OLAP solution at all. So, a lot of people try to layer OLAP on top of Databricks just because Databricks is bigger. The challenge with that is that, your pool keeps getting bigger, and the more functions you put on it. So I'm willing to bet that the performance, is for Pinot for OLAP function is much better than the Databricks for transaction processing. Databricks is amazing. For OLAP, you should consider Pinot.
Okay.
Yeah, I'm going to put it into the chat here a link that you might find of interest. This is already a couple of years ago. This is already 3 years ago, but this talks about how Uber was operating Pinot at scale, and it also mentions a little bit about their use of Spark as well. And so they made choices as to what to keep in Spark natively, and then what to also do in Pinot. So there, again, but it's really situational dependent. I don't want to give like a hard and fast rule, because obviously every organization has their own proclivities. So, but again, I'd be interested in hearing more currently how you use it. And then, again, I'd want one of our engineers to really hear what your use case is and see if it's an appropriate offload from Spark to do some things in Pinot. Now, one of the big things I'm going to say is that a lot of Spark jobs are actually really small data. Like,
Right.
A lot of Spark jobs are actually just a teeny tiny cut of a huge swath of data that you might have in a data lakehouse. But really, the experiment that they're running is on maybe even megabytes. They're certainly sub-gigabyte scale data, right? Whereas Pinot, you're going to be running against terabytes potentially. right? So again, a lot of this depends upon specifically what data set that you have, what kind of analytics you need, and how large the segments of that data you're working with, and then also timescale. Again, Pinot is designed to get results in seconds, for very large data sets, whereas again, Spark is usually not time bound in the same way. So you usually have more time to run a Spark job, maybe even measured in minutes. So again, a lot of this really depends upon the specific use case. And so I don't want to provide a kind of hard and fast rule. There's a lot of nuance here.
Yeah. And so I totally get the the snowflakes and the Databricks for OLTP. Absolutely. And trust me, I had at least 50% of the Snowflake Databricks clients coming to me with a quote unquote cheaper reporting solution, which is what Pinot, and that's why I think that Pinot is, again, it's a OLAP solution at OLTP speeds. And to me, that is the piece that kind of syncs. And if you're running into OLAP issues, then Pinot is definitely worth looking into.
Yeah, and again, just like we're not going to replace your OLTP database, we're not going to replace your event streaming system, right? Pinot becomes an additional tool in your toolkit to get the results the business needs at scale, right? So a lot of this really depends upon your current architecture and the current problem that you have, and to see where and when and how Pinot is an effective tool to add to that, but it's not really going to be replacive. You're not going to throw out Spark anytime soon and say, oh, well, Pinot is going to take care of everything that Spark used to do. Different tools, different purposes.
All right. Well, thank you all for joining me. I appreciate your time.